Welcome to the sixth example in review of statics. The question reads, determine the shear force and moment at points C and D. Okay, so we start with givens, and in terms of givens, I don't think there's actually much we can write here. We're just going to say diagram, because everything we need is going to be in the diagram or in our free body diagram. So next is unknowns. What does the question want us to find? Well, from what I can see, the question wants us to find the shear force at point C, the shear force at point D, as well as the moment at point C and the moment at point D. We can move on to a free body diagram of the beam. And if it kind of looks like this, and even though the diagram's right there, it's good to redraw it yourself just to have that connection mentally. Because if you redraw it, like, I don't know, at least it helps me better visualize the problem. We're going to have D right there, and we're going to have B. If we roughly sketch the dimensions as well, we have something over here as well. So, okay, this is 2 meters, this is 6 meters, 4 meters, 4 meters, 6 meters as well. Okay, what else do we need? Now we can add the forces. I see one force right here, and that is 500 newtons in magnitude. A force at point D, 200 newtons, and we're going to say plus y plus x, that's our coordinate system, and we have a force at point E. Perfect. Is that all the forces we have, or at least the external forces? When we end up sectioning the beam, we can look at the internal forces. Now we're just talking about the external forces. Do we have any more external forces? Well, we actually do. Due to this pin connection, as well as this roller connection. There are different types of connections, and each one of them causes like different reactionary forces. If there's an example of a fixed connection, like a beam like so, you'll have like a moment, you'll have an X and a Y component that you have to add. There's rocker connections that look kind of like this. So you basically have to memorize all of them to know what components you will have. For a pin connection, as you have at point B, you're just going to have a Y component and a X component, which is called BX and BY. This ball connection, you're just going to have a vertical component, so AY. So we're going to add those in this color. So AY, you have BY, and you have BX. If you just do the force summation in the X direction, you automatically know this is the only X force we have. So this is going to be 0, so no need to even like consider that. And the question is not asking us to find a normal force, so that's also a hint that the X forces or the X summation forces, there's no forces in the X direction basically. But perfect. Now we have all the external forces. The next step is that we want to section this beam. We want to look at just this section AC, and then by splitting this section up, we're going to then like induce or like cause, or once we section a beam, once we cut it like that, we're going to have to add a normal force, a moment force or a moment, as well as a shear force. And then we can do the summation for just this little segment with, for example, in this case, AY and 500 newton meters or whatever, or 500 newtons. So that's the game plan. But before we do that, I want to determine what BY and AY is, because I might need them in my calculations. I'm just going to tell you that if you take a moment about point A, what are you going to get? Well, you're going to have this force, 500 newtons. You're going to have this force that's going to cause a moment. You're going to have BY that's going to cause a moment. And you're going to have negative 300 or 300 newtons that's going to cause a moment, right? You have 1, 2, 3 knowns. You have one unknown in one equation. And AY, again, R cross F is equal to the moment. Therefore, the force at A will not cause a moment because R is 0. So basically, you have one unknown in this equation. And by doing that, you can find BY, right? So if you take a moment about A, long story short, you're going to find BY. How do you find AY? Once you have BY, you can just take the sum of the forces in the Y direction, and then you can find AY as well. I will give you the values. You are going to get that AY is equal to 114.29 newtons, and you're going to get that BY is equal to negative 885.714 newtons. And this basically means that we just we didn't guess this properly. By actually acts in this direction. Perfect. Now, as we said, to find the internal forces or to find the shear force and the moment at point C, we want to section the beam like this. So we're going to take the section AC, take the sum, and then we're going to do the same thing on this side. We're going to section it. I think this is DE. Perfect. So if we take as number 4, section AC, the beam is kind of gonna look like so. So we have this is point A and this is point C. Whenever you cut a beam, let me keep this in frame. Whenever you cut a beam, you're gonna have an M, so a moment, N and C, and then V. So M and V. Nice, simple. I don't know. Does it rhyme? I don't know. Okay. Okay. So this kind of looks like this in terms of dimensions. So 6 meters, 4 meters, and then we have our force 500 newtons here. We have our force AY, which we know to be 114 newtons. Okay, how do I find VC and how do I find MC? I already know from, again, summing the forces just in my head, or you shouldn't always do it in your head, but like in this very simple case, you know that NC is going to be 0 because it's the only force in the X direction, and we don't care about it in the first place. Okay, what happens when I take a moment sum about, for example, just point C? If I take a moment sum about point C, I'm going to have this force that's going to cause a counterclockwise moment, so normally positive, right? And this is the R. I'm going to have AY, which is going to cause a clockwise moment, right? And I also have MC, which I assumed counterclockwise, right? So I'm just going to include all 3 of those in my calculation. If I take a moment about point C, I'm going to have, and I say that this is positive, I'm going to have MC plus 500 times 4 meters, and then minus AY, which I know is 114, but I'll just keep it as AY, times 10 meters, right? If you do this calculation, you're going to end up getting that the moment about point C is equal to negative 857 Newton meters. What does that mean? That basically means that instead of this moment acting counterclockwise as we guessed, it actually acts clockwise, right? That's one of your answers. Perfect. The next step is a bit easier, and we should have did it first, to be honest. But that's just a sum of forces in the Y direction. And another thing we should say is this is equal to 0. It's just a formality. Okay, or it's not a formality, but you should know that. Okay, the sum of forces in the Y direction. You have very simply, you have AY minus 500 minus VC. From this, you're going to get that VC is equal to negative 386 newtons. And again, that's the exact same concept we set up here. That basically just means that we guessed our VC force wrong. We assumed it to be downwards in the negative Y direction, but actually it's in the positive Y direction, like so. Okay, now we can just do the last section. So that is section DE. And we're going to do the exact same thing, right? If that's our section. And then we have point E right here, and this is point D. We have this entire section being 2 meters. We have this force right here being 300 newtons. And again, when we cut a beam, it's going to be M and V. So you have M, D, N, D, and then they're like that, VD. Sorry, that's a bit crowded, but again, ND automatically 0. We don't have any other forces in the X direction. If we take a moment about point D, we're going to have this force, and we're going to have this moment that we said occurs at point D. And again, this is different from, like, you might ask, okay, why do we have a moment here? Why do we just add it? This is a moment. It's not a force. Like, you might say, oh, but it's acting at point D. I know, but it's a moment. It's not a force, okay? That's something very important, so you don't get confused. But yeah, if you take the summation of the moments around point D. This is a clockwise moment, so it's actually going to be negative. And then this will cause a clockwise moment again. Yep, it will cause a clockwise moment again, so it's going to be negative 300 times 2 meters. This is equal to 0. You're going to find that the moment in, or the moment at point D is equal to negative 600 Newton meters. And again, that's the exact same thing we said 2 times now. Basically, we guessed the direction wrong. It actually acts like this, right? It actually acts counterclockwise instead of clockwise. Okay, we're going to do the sum of forces in the y direction. And all we have is that VD minus 300, VD is equal to 300 Newton meters. And this time we actually did guess the direction correctly. And there you have it. You have at point C, you have your moment and your shear force. And at point D, you have your moment and your shear force as the question